Woohoo! We are live. This is Math 40, Elementary Algebra. This is 1.9, Simplifying Algebraic Expressions Using the Properties of Real Numbers. Remember that real numbers are the numbers we were just talking about a few sections ago. They're basically all the numbers that we're going to be using. So we're using the full set right now for this class. And we're going to talk about properties that we all can agree are true. So what does that mean? Well, we've got lots of names because mathematicians love naming things. So first we've got the very difficult to say commutative property of addition, or if you want to be fancy, it's the commutative property of addition. Basically, it comes from the same word, I believe, as the word to commute. And basically it says, if I add A plus B, I will get the result as if I add B plus A. So in other words, if I take two numbers and I switch the order, the addition stays the same. So let's check this. 3 plus 4 is 7. 4 plus 3 is 7. Nice. Now, here's the thing. Showing you an example does not prove it. It just explains kind of what's going on. For example, if I say right now I'm barefoot, so everyone must be barefoot, that's not necessarily true. So one example does not prove it. It's just a way to look at what we're talking about. And what I'm talking about here is if I change the order, the sum, the addition, stays the same. We also have a commutative property of multiplication, or commutative, again, if you're going to be fancy. If I multiply 3 times 4, that's, okay, everyone get out your calculators and your toes and your fingers. You got it. That's 12. And then if I write it as 4 times 3, what do I get? The same thing, 12. Yay! Again, not proving it, just showing you an example. So now when we get very excited about the commutative property of addition and multiplication, maybe we think, well, everything works that way. Well, my question for you is, does subtraction work? Does it work for subtraction? Think about it. If I take 4 minus 3, is that the same thing as 3 minus 4? If I change the order? No. Nope. Subtraction does not work. There's no commutative property of subtraction. So we got to be careful. If I'm going to use this property, it's going to say I can move things around if they're added, or I can move things around if they're multiplied. Okay, so two good properties to know. Next up, we've got another property that looks really similar, except this one has parentheses in it. So this is called the associative property of addition, or associative property of addition. Let's take a look at it. It says in parentheses A plus B, and then plus C. So if A and B are stuck together, and then C is on its own, that it claims that's the, sorry about that. That gives you the same answer as if A is all by itself and B and C are together in the parentheses. Couple things to notice. Notice that it goes A, B, C on both sides. So this is not the commutative property. Nothing has changed on order. All that's changed is where the parentheses are. So if I get out my handy dandy highlighter, A plus B right there, B plus C right there. Different variables are getting added inside the parentheses, or constants. I haven't said what they are. So let's try an example. If I have 3 plus 4 plus 5, so this says you add the 3, but you know what? I don't like this at all. I'm going to get another piece of paper. I know, I'm going off script. but I realized I don't want to have to fit this onto a paper. So let me do 3 plus 4 inside parentheses plus 5. So that looks just like this a plus b in parentheses. Or you can say the quantity 3 plus 4, and then pause for dramatic effect, and then say plus 5. The quantity 3 plus 4 plus 5. Let's take a look at this. That tells me, I can use my highlighter here, I am supposed to add the 3 and the 4 together first. 3 plus 4 is 7. Now, what is 7 plus 5? 12. You got it. Now, how does this compare? I'm going to put a question mark up here because I'm not sure. Let's see. What would the other way of writing it? Well, I'd have the 3 first, and then the 4, and then the 5, but the parentheses would be around the second two. So 3 plus 4 plus 5. So in other words, if I have 3 numbers, does it matter which 2 I add first? So let's look here. This is going to be 4 plus 5, so that's 9, and I bring down the 3. 3 plus 9 is, look at that, it works. Now, can I see how it's working? Sure. This one, I'm going to add these 2 together and then the 5. This, I'm going to add the 5 right off and then add the 3 at the end. Here's the thing. As a human, and here I have spent many years being human, and I've learned something, and that is that humans are very good, because we have 2 hands, we're very good at adding 2 things together. We are absolute rubbish at adding 3 things together. Maybe jugglers are good at it because they're used to, dealing with more than 2 things. But most of us add 2 numbers at a time. And what is this rule telling us? Well, the associative property is telling us if you have a 3 and a 4 and a 5 and you want to add them all together, you can add whatever 2 you want to start with. The first 2, go for it. The last 2, go for it. And in fact, I'll tell you, you could even add the 3 and the 5 to get 8 plus 4. That would also give you 12. So you're allowed to add it in any order you'd like. That's the associative property. And it's the associative property of addition. So let me write next page, so I don't forget that I put this over there. Let's do the associative property of multiplication. So if I have 3 times 4 times 5, will that give me the same answer as 3 times the quantity 4 times 5? Notice I used implicit multiplication there. I wasn't thinking, I just wrote it in there. You can write it in. It just looks a little funny. It's like an extra thing that you weren't expecting to see, but it's perfectly fine. However, the cool kids are going to write nothing in between the 3 and the parentheses. So I could have left this multiplication out there too. I'm just not cool all the time, I guess. Okay, so over here, I'll use blue again. I'm feeling very blue today. I'm going to multiply. 3 times 4 is 12. Now I have to multiply by 5. Now, if you know your times tables, 12 times 5 is, everyone's like, oh no, what is it? It's 60. And here I'm going to have a little advertisement. I'm going to say, honestly, if you're taking Math 40 elementary algebra right now, there's a good chance you've got more math in your future. Some of you might not, but many of you will. And I would encourage you to have, get out your cards. Make sure you've got, oh my goodness, I don't have one here. No spare cards? Have cards and actually write 3 times 12 or whatever it is. And then on the other side, it would say 36. You got it. So have a set of cards and practice. And when you ask me, well, how far should I practice? I would say know your times tables to 13. I know it's a lot, but the more you know your times tables, the easier math is going to be. Okay, so we'll come back over here. What were we doing? Oh, that's right. We were going over here. We're checking the right side. 4 times 5 is 20. You got it. 3 times 20 is 60. Did it work? It did. And again, I'm not proving it. I'm just showing it. So this is the associative property of multiplication. I learned to pronounce it associative, so very fancy. Okay, so what does that mean? 3 things. If you've got parentheses saying these two first, these are good friends, these are good friends, it does not matter as long as it's all addition or all multiplication. Now, what are you going to guess if I said, do you think it works for subtraction or division? And the answer is no. Subtraction and division, they're cranky. They're not always anyone's friend. Yeah, they're decent operations. They're gonna be useful, but for the most part, they are not gonna want to play reindeer games with us. So we're kind of out of luck there. Okay, so now a new property. I know I had to get everything straightened out for the new property. Dun, da, da, da. The distributive property, otherwise known as visiting the family. I learned this from another teacher who teaches with visiting the family. It's very exciting. I loved it. So the distributive property is the one, let me just write it out for you. It looks like this. A lot of times it's the one with the arrows over the top. And it says that if you have a number outside, multiplied times parentheses, and there's a b plus c, something plus something inside, you can actually say a times b plus a times c. So in other words, instead of adding these together inside, you can multiply the a there and the a there. So why is it called visiting the family? Well, this only works if you're in the kind of family where your family members live far apart and they keep track of how often you visit. Now, if you have one of those families, then you'll know if you go to visit one auntie in New Jersey, the other auntie who lives in Alabama is going to keep track of that and is going to expect that then you will go visit the auntie in Alabama. They will get very cross if you don't keep visiting each of them the same number of times. So the idea here is if there's an a outside a set of parentheses, you can multiply out is what we call it. A goes to visit the B, A goes to visit the C. Now, notice a weird thing about this. On the left, A is only written once. On the right, there are 2 A's. Some people get really caught up in this. They're like, wait, there's an extra A. What happened? Is this magic? And the answer is you say, yes, it is. I am a great magician and you should give me all your chocolate. But in fact, no, it's not magic. This is saying A is going to multiply here and here. So it's like shorthand. Here you're actually saying A multiplied times B and then A multiplied times C. So you're just writing the whole thing out. Let's take a look at this. So what is 4 times the quantity 5 plus 3? If I have 4 times the quantity 5 plus 3, order of operations, the order I'm supposed to go in says parentheses happen first. Dun, dun, dun. So I have to add the 5 and the 3. As you can tell, I've got a cat who's very excited about math. Can't get enough math. 5 plus 3 is 8. What is 4 times 8? 4, remember that's multiplication, implicit multiplication. 4 times 8 is, again, practice your times tables, 32. I always had trouble with this one growing up. I still have trouble with it. I had trouble with it just 2 minutes ago. Oh, this is the one downside. When I'm in a classroom, you guys all yell the answer at me, so I don't have to know my times tables. I'm going to have to really step it up if I'm going to make videos. Breaking up the multiplication into 2 pieces, what does that mean? Well, what if I take the 4 times the quantity 5 plus 3 and I spread it out? I multiply out. I say 4, and the arrows can go underneath, by the way, in case you'd ever wondered. The arrows can go wherever you want, wherever they will help you. 4 times 5 plus 4 times 3. So let's take a look at what happens. 4 times 5 is 20. What's 4 times 3? You got it, 12. What's 20? My mouth is just not doing the English tonight. 20 plus 12 is, oh my goodness, we got the same answer. So what's happening? Well, here what we're doing is we're bringing the 5 and the 3 together so we can do one big multiplication. Bam. Here what we're doing is we're doing little pieces of it. We're saying let's do a little bit here to get 20. We'll do a little bit here to get 12, and then we bring it together. That's the distributive property. Okay. Woohoo. Let's go to the next page. What do you think is there? It's going to be fun. I bet it is. There it is. I wrote it out all fancy, and you have a copy of these notes, so you'll have a copy of it being all pretty. The distributive property, notice that if it's A times the quantity B plus C, I get AB plus AC. So again, the arrows, like that. But if there's a minus in the middle, notice there will also be a minus in the middle. Okay, shall we practice? Don't look at those. They will stress you out. Let's start with these ones up there. Okay, so this one is 3 times the quantity 4x plus 5. Okay, I'm going to draw the arrows. Do you have to draw the arrows? No, of course you do not have to draw the arrows. Really, you don't have to draw the arrows. They're just supposed to be helpful. So 3 times the 4x plus 3 times the 5. 3 times 4x is 12x. 3 times 5 is 15. What do you guys think? I know this is a little bit edgy. Some of you, it's been a really super long time and variables haven't really happened in your brain in a while, or if perhaps you just for whatever reason never took algebra, this may be a little exciting. And what I promise we will do is we will spend a lot more time talking about this. And in fact, the next half of the next video we're going to do has to do with like terms and variables. So we're going to keep coming back to this over and over again. So I got 3 times 4 is 12x and 3 times 5 is 15. Woohoo. Okay, what if I put a minus in the middle? So it's 3 times the quantity 4x minus 5. Good question. Again, arrows, but only if you like the arrows. I get 3 times 4x, and look how I'm going to write this. Now, different people have different styles. I personally think that minuses just mess you up. I know they can be fun. I know a lot of people have experimented with minuses, especially in your teenage years. They seem very cool, edgy. All the parents are like, oh, don't do the minuses. And you're like, no, I'm going to do the minuses. But I actually think they will mess you up. So I'm going to get the minus out of the way and just put it right there. I know a lot of people do it differently. I'm just putting it in the middle. That minus that's in the middle right there is this minus right there. I'm not messing around. Okay, well, maybe 12x minus 15. So 12x plus 15 with a plus in the middle, minus the middle, 12x minus 15. Woohoo, woohoo. Okay. Dum, dum, dum. This one. Oh, this problem. Now, again, if you're a little on the rusty side, if you haven't done this in a long time, don't panic. Don't panic. That's all I can say is just don't panic. We're going to keep coming around, doing a lot of work. It will start to make sense. What is happening here? Negative 3 times 4x. And then I need, I'm going to bring this over here so you can't see what's coming because I'm worried that you guys are going to worry about that and then it's going to make it harder. I need my Bat Brothers. Here are the Bat Brothers. They're each a minus. What happens when you take two minuses and multiply them together? becomes a plus. Let's do it again. 2 minuses become a plus. Okay. We leave them up there as lovely support animals for us. We need a lot of support while we're doing this. Okay, so this -3 went to 4x like that, and then the -3 went to this -5. 2 minuses in a row. And again, like I said, I deal with the signs right out. I don't do any of this minus a minus. I just write the plus because I find the 2 minuses in a row too much. If you like writing the minuses together, go for it. Go for it. So notice what happened. When I had 4x minus 5 in the inside the parentheses, and I multiplied by a positive 3, the first one was positive and the second one was negative. When I multiplied by a -3, the first one was negative, the second one was positive. So I just changed all the signs. So an additional, when you throw an extra minus into the mix, you just end up with everything being the opposite. You're in an opposite land. Okay. Take deep breaths. Maybe pause and look at a picture of puppies or grab a pet or a stuffed animal. You guys ready? We can totally handle this. I know. Fractions. I know everyone's running, screaming from the room. But the goal would be that fractions get to the point where it's no big deal. And you know how no big deal it is? I'm going to write it really big, which I know is kind of counterintuitive. But I really should have given this more room. This is number D, 10 times the quantity x over 2 plus 3/5. Counterintuitive to write the scary thing big, right? Because what we're supposed to do as humans is make everything look small and then we feel better. And the answer is no. When something is written nice and big, there's no room for shenanigans. There's no things getting too small and magical stuff happening. We don't need any magic in our math. There's plenty of magic in the world without needing it to happen in our math. So I'm going to go ahead and I'm going to do what I can. Now, it could be that what I can do is not all of it, and that's okay, but at least I'll get it started. So the 10 comes over here, so I've got 10 times x over 2, plus the plus in the middle, 10 times 3/5. Okay, next thing I realize is I'm dealing with fractions, so I actually should rewrite the 10 as 10 over 1. This is going to make everything easier. Get the entire math problem into the same language. These are in fractions. Let's put the 10 into fractions. So 10 is 10 over 1. Okay, now I need my red pen because I've got multiplication. Look at that multiplication. I can reduce. The 2 reduces with the 10 and I get 5. And then I'll show you something cool. Since there's a plus in the middle, we can actually do this one at the same time. The 5 cancels with the 10 and gets what? You got it, 2. So let's look at what we've actually got. All of this becomes 5 over 1, or 5 times x over 1, which is x, plus this one becomes 2 over 1, 2, and 3 over 1 is 3. 5x plus 6. Just like that, no shenanigans, nice and big. Okay, so far so good. A little bit, I know it's a little edgy. I realize that. You guys are doing awesome. Just keep breathing. Keep your feet on the floor. Remind yourself that the sun will come up tomorrow, one hopes. The earth will keep spinning. Math, so far in the history of humankind, math has never been the end of the world because the world has not ended yet. I have a feeling it won't be math if it does end. Okay. I'm writing this down. Again, I'm writing really big letters and numbers so that no shenanigans, no room for any shenanigans. Negative 0.5 times the quantity, big quantity, 2t minus 3 plus 0.2w. Notice I've got 1, 2, 3 things inside. So this is like a supersized distributive property. This is a big family. I'm going to go visit my family in New Jersey, my family in Alabama, and my family in Arizona. Negative 0.5 times 2t. Okay, so far so good. Now for the 3 has a minus in front of it. The 0.5 has a minus in front of it. What happens when we get those two crazy bad brother minuses together? Oh, it turns into a plus. See how happy they are about this? This is great. Plus the minus becomes a plus. 0.5 times 3 minus 0.5 times 0.2w. So, and then it would be fair if you were a human to look at this and go, wait a minute, why did you put parentheses here and not here? And I'm not really sure why, but since I want to be consistent, so let me put parentheses all straight through. I don't want anyone worrying that there was a reason for that other than I just am feeling peculiar, I think. Okay, negative 0.5 times 2t. I happen to know that 0.5 is 1/2. Times 2 is 1. However, you can always double check this. And let me remind you, when there's a minus out in front of a number, when you're going to check, you use the funny opposite sign, not the minus sign. If you try to use the minus sign, it will just confuse the heck out of your calculator. So you change the sign, 0.5 times 2. Now, I'm not going to try to type in the t, because I know the t is just going to hang out. So I'm just going to do the coefficients or the numbers, and I get negative 1. Okay, 0.5 times 3. Do you guys know that? 5 times 3 is 15, so 0.5 times 3 is, you can always do it on the calculator. You got it, 1.5. And then here, now this one, I always have trouble with this one, so you're going to see me do this one. Negative 0.5 times 0.2, because what happens? It ends up being 0.1w, which really weirds me out. That 0.5 times 0.2 gives me 0.1. There you go. Okay. Is there anything that adds or subtracts? No, we're done. You guys made it. Nicely done. That was the first part of 1.9. I'm going to go ahead and make another video. If you need to take a break, take a break. Get something, get a snack. Snacks always make the world better. Get something to drink. Remember to get a little exercise. Remember, this is not the end of the world. Okay. Woohoo, guys. Math on.